Hi, my name's Mike Meacham. I'm an engineer here at the Jet Propulsion Laboratory, and I want to talk to you about some of the technologies we're developing for landing bigger and heavier things on Mars. One of which is a much larger supersonic parachute. When we land spacecraft on Mars, we're going extremely fast. We have got to slow down, so we use a parachute, and we use a really big parachute. To make these large parachutes, you have to test them before you go. You need a way to apply the same load that you're going to feel on Mars, and you need a way to do that here on Earth. In the past, we've always used a wind tunnel, but the parachutes themselves are getting so large they don't fit in any of these wind tunnels anymore. We needed a way to apply the same type of wind in a controlled way, and we had to get outside of the building. If you want to go to Mars, you want to go big, then you've got to test big here. You've got to be a little crazy sometimes if you want to do the crazy things. The crazy idea we came up with was to attach it to a rocket sled and have that rocket sled pull it around a pulley with a huge 1 kilometer long rope. And the way you have to do that is extremely complicated. Remember that game Mousetrap when you were a kid, when all these little mechanical things had to happen in sequence? This test is a lot like that. There's a whole bunch of stuff that's got to happen in sequence, one after another, for us to be able to test this parachute. First, a Nighthawk helicopter's got to pick this parachute off the ground inside of a bag. Underneath that's an instrumentation plate. Underneath that's almost 1 kilometer of big, heavy rope. At the bottom of that rope is a 2-foot long steel bullet. It weighs about 100 pounds. That's all swinging up in the air underneath this helicopter. At the bottom of that bullet is a fishing line, a smaller nylon line that goes another 400 meters or so, all the way down to the ground, through some rollers, down through some pipes, around a pulley in the back of the sled, attached to a 300 horsepower winch. That winch is turned on all the time, pulling on this parachute. The helicopter releases the parachute. The winch spools up, sucking the parachute down towards the ground and maintaining tension through the whole line. Our parachute's now inflated, our winch is still spooling it in, and it's pulling that bullet right down to the ground through all those same rollers, same pipes, into the back of the sled. As soon as that bullet latches into the back of the sled, we've got the parachute. We cut away that fishing line, turn off the winch, light the rockets, and now our rocket sled is pulling our parachute down toward the ground around a pulley. And that's our outdoor wind tunnel. Okay, so you're seeing the parachute rip, right? It looks bad. It's not as bad as it looks, because really the point of these tests is to find these flaws. We want to see how far we can push these parachutes. We want to see what's wrong with them. And more importantly than anything, we want to see if it happens here on Earth before we spend all the real big bucks and go to Mars.